All right, let's continue. Find the slope and y-intercept of each line. Now this time we only have an x equals a number in our equation. Now since this cannot be written as y equals mx plus b, we're going to pick 2 or 3 points such that the x coordinate is 2. Now in class we just made up 3 points, 2, 6, 2, 1, and 2, negative 4. Notice every point has an x value of 2, satisfying our equation. Connecting these 3 dots, we have a vertical line. There's no y-intercept, and the slope is undefined because there's no horizontal change. Over here to your left, remember our verbal description of slope, it's vertical change over horizontal change. If a fraction is undefined, it has to have a 0 in the bottom. So that's why we say 0 in the denominator, no horizontal change, undefined slope. And that's going to be money in the bank anytime your equation's just x and a number. Vertical line passing through the x-axis at that number. Let's look at our next equation, 3x plus 2y equals 12. We need to solve where it'll say y equals. So I'm going to subtract the x term on both sides. That'll leave us with a 2y. On the right side, 12 and 3x are not like terms, so be careful not to call that 9x. If that were 12x minus 3x, you could call it 9x. But in this case, we're going to leave the x term, and I'm actually going to write it in front and then scoot this plus 12 down so it's on the end. Divide all the way through by 2, and that will give us a y equals mx plus b format. If your fraction won't reduce, that's okay. Don't force it to. If you can divide evenly, go ahead. 12 over 2 is 6. So we have a slope of negative 3 halves and a y-intercept at 0, 6. Plot your y-intercept first, and then use your slope to count down 3 over 2, put a dot, down 3 over 2, put another dot. They will all line up if you're doing it right. This graph actually works out where we can see an x-intercept clearly, and that occurs at the point 4, 0. This problem didn't ask for an x-intercept. We just needed to identify slope and y-intercept, and we have. Find the slope of the line passing through the points negative 2, 4 and 3, negative 5. First, let's go ahead and plot these. Negative 2, 4, left 2 up 4, there's where that point located. 3, negative 5, from the origin we go right 3 down 5, so we've identified our points. In class we discussed people who prefer visual learning to formulas. We're going to do it both ways. To get from negative 2, 4 down to 3, negative 5 using vertical and horizontal changes, we count down a total of 9 units and then over 5 units. Down 9 over 5 translates to negative 9/5. Visually, you can just do a stair step, and that's just fine with me, whichever way you prefer. Now, if you're using a formula, also we discussed in class that subtraction is nothing more than distance between two numbers. You can count from 4 to negative 5, that's a total of 9 units. If we subtract 4 minus negative 5, we get a total of 9 units. From negative 2 to 3, that's 5 units. 3 minus negative 2 is 5. The catch is when you use the slope formula, you must subtract in the same direction both times. Therefore, if you're going to subtract from left to right, 4 minus negative 5, You also have to subtract left to right with your x's, -2 to 3. We're going to get a -9/5, which matches our verbal description earlier. And again, you guys pick whichever way you learn better, whether you want to plot your points and count the slope, or if you want to use a formula. They will both give you the same result if done properly. The catch is with the formula, you have to subtract in the same direction both times. Find the slope of the line passing through the points 2, 4 and 2, -5. 2, 4, from the origin, we go right 2, up 4. 2, -5, from the origin, we go right 2, down 5. The vertical distance between the points is 9 units. There is no horizontal difference between those 2 points. I see something I need to fix. Over here, I've got to scratch that out. I actually wrote that upside down and nobody in class caught me. Vertical change, we had 9 units. Horizontal, none. 9 divided by 0 is undefined. So I had a -2 in class, and I may give y'all a -2 for not catching it. I'm just teasing. You guys are great. Vertical lines will always have an undefined slope. Find the slope-intercept form of the equation of the line with the given slope passing through the given point. This time we're going to go backwards. Instead of having an equation where we just pick out the slope and the y-intercept, we're going to be given information about a line and we've got to try to find that out. A slope of -1, this point 0, 7, if you plot it, 0, 7 is up here on the y-axis. Now, since that point's directly on the y-axis, it's a y-intercept. We're given slope. Let's immediately go over here to the top right. Slope-intercept form, y equals our slope times x plus the value of y at your y-intercept, +7. It's okay to write a -1x plus 7. The one's not required. They're always understood if a variable follows. So our equation of this line is y equals -x plus 7. On our last example, we have slope of -2 and a point -4, 8 given. Remember, any slope that's an integer, you can create a fraction by dividing it by 1. It'll retain the same value. By doing so, it helps you graph. Let's plot -4, 8. From the origin, we go left 4, up 8. There's the point given. Now this time, the point given is not directly on the y-axis. A lot of times that's the truth. You're not always given a point on the y-axis. But let's be patient, count off our slope. A slope of -2, that means our line falls 2 every time it runs 1. Starting at our point, fall 2, run 1, down 2, run 1. If you repeat, you'll find that the graph crosses at the origin where y is equal to 0. That's a good break for us because when we go to slope-intercept form, the slope was given, that's -2. So we have y equals -2x. The value of y at the y-intercept is 0. It's your second number, plus 0. You don't have to write a plus 0. So the name of this line is y equals -2x. Slope of -2 and an understood 0 for the y-intercept.